Now, as we start page 100, I had actually with this joined with another set of pages, but decided to put it all by itself because this is rather intensive and lots of things to go on. So what do we know? Well, we have set Z, which will designate this as set C. And we know that all of this is 0.46%. And we have set Y. And all of this is 0.42%. Now we also know, because of this, that the intersection of these two sets is 0.18. So this is a good little tool that we had before. So how do we find what, if all of Z is 48, what is this part here? And I'll put that in blue. Well, if we subtract the 0.18 from the 0.46, we get 0.28. And if we subtract the 0.18 from the 0.42, we get 0.24. Now, if we add these three up now, we will get what the union of Z and Y are. And that would be 0.70. Now I'm doing this in some detail here so you can see how we get our values in here. Well, if the sum of the union of this, what would be left outside of it? Because again, this is 100%. And if we subtract 0.70 from 100%, we get out here then, this is 0.30. So we will keep these figures in mind as we do all of these Venn diagrams. And again, you can either take notes on it or follow along to see the pattern. This one is pretty much the same as this one. They give you the same kind of information, and we'll let you have a crack at doing this one based on this and these, because these are all the same. Just going to give you a chance to practice. So now that we have our values, this is the universe, we're looking for what is the complement of Z intersecting with the complement of Y. So let's shade the complement of Z first. And I think we would all agree that this is the complement of Z in yellow. Now we're going to shade the complement of Y in red. So we can see that this is Y, and then the complement of Y is streaked in red. So now what we want to do is see where do we have intersection between the yellow and the red. Well, we have it all through here, and that is the intersection of the complement of Z with the complement of Y. And the ones that have two, it's right here, 0.30%. So this is going to be 0.30%. And we've done one like this earlier in our course, when we did this type of thing. All right, let's take a look at Part B. Now, in Part B, we have the same figures, point 28, point 18, point 24, and point 30. And if we were to color the complement of Z, that would be the yellow. The complement of Y would be our red stripes. But now, since we want union, we're looking for anything that is colored. And we're now going to say, well, we can actually use this diagram, but what is not colored here? Well, what is not colored is the 8.18. Everything else is colored. So how could we figure this? Well, we could go probability is equal to 1, which is the whole, minus the 18. And that would give us, for this one, the probability is 0.72. Well, that's close. Yes, 0.82 is much better. 82 plus 18 is 100. So we can use the same diagram. We could do it again. We get the same results, but now because of union, we're going to take everything that's colored, not just where they intersect. Now in 1C, we're going to shade this. We want to shade in yellow Z complement. So everything but Z. So there is our Z complement, everything but Z. Now we're going to do union, so we want to shade Y. So for this, we can use the red again, and we're going to shade Y. Now, again, what is left here? What is not colored? Well, you might say 28. No, it's not 28. Oh, I'm sorry. It is 28. I was thinking that this full thing. So 28 is the part not colored, because 28 plus 18 would be Z. All right, so we have 1 minus 0.28 will give us 0.72. So again, the complement of Z, all of the yellow, in union with the Y, gives us everything except the 0.28, which we subtract from 1 to get our answer of 0.72. Into example 1D now, we want to have Z intersecting with Y complement. So I've shaded in yellow what Z would be. Now I'm going to use red to shade in Y complement. And since it's intersection, we're looking for where is the yellow with the shaded red. And that comes up here quite obviously as 0.28. Now the next examples are going to be very, very similar to this, except they're going to change these numbers inside. So let's set that up. So the data they're giving us is that Z is 46, Y is, well, 0.36, and the intersection between the two is 0.16. So we're going to put our 0.16 right in there. And all of this is 46. So if we subtract 0.16, we're going to get 0.30. And all of Y, we said, was 36. And if we subtract 0.16 from 36, we get 0.20. And if we add all of this up now and subtract it from 100, we get out here 0.34. Now with that, you're going to repeat what we did above because it's the same thing. It's P, the probability of Z complement intersecting with Y complement. And you recall above that was 34. So again, I have these all written out in my book. I want you, though, to try them and see what you get. So in letter B, again, we said we could use this. Whatever's here, we subtract from 1.00, and for 2B, we get 0.84. And down here, for letter 2C, very similar to what's above, we're going to subtract 1, or from 1, 0.30, and for 2C, you're going to get 0.70, and for 2D, once you color in Z and Y complement, and the intersection of that comes out to 0.30. But again, you should try to do this, and it's a similar pattern to what we did up here in example 1. Now in example 3, the parameters are Z is 0.50, Y is 0.30. Now they're not giving us the intersection here. They're giving us the union. And if we add these two together, we get 87, not 0.71. So what do we use? Well, again, going back into what we had before, it will be 0.50. This is Z plus 0.37. This is Y. Now we have to subtract then that part that would be intersecting because those numbers are repeated, and then we get the total of 0.71. So if we do that and add these together, this is going to be 87 minus now the 71. We get here 0.16. So that's the method. Again, we did some of this in the past, we want to find out what our intersection is. So we can now say our intersection is 0.16. Well, if this were 50, then this part will be 0.34. And if this was 0.37, this will be 0.21. And now if we added up these three, that would be 0.71, which is our total of all of this. So then what would be outside of this to make 100% would be 0.29. Now, so the same procedures are done for 3A as we had above, now that we know what our items are inside. So let's just do this one again. So we're going to do Z complement, and we'll do that in yellow. So I think we can all agree that this is, in yellow, Z complement. Z is not there. Everything outside of Z is Z complement. We're now going to sketch in red Y complement. So everything outside of Y. And the way this is set up now, we're looking for intersection. Where do we find yellow and red together? And we have it summarized again as what is outside here. So this is going to be 0.29. Now for letter B of 3A, we want this, but instead of being intersection, we want union. So it's wherever there's color. Well, there's color everywhere except here. So we're going to take our 1 minus 0.16, which is not colored, and this will give us 0.84. So you can, if you've done these others, you can use a similar process. And let's do 1D now, or section. So our data here is Z is altogether 46, Y altogether is 0.36, but in union it's 0.66. So if we follow that same protocol, 0.46 plus 0.36 minus some value of where they intersect, this will reach 0.66. So let's figure that out. So if we add these together, we get 0.82, and if we subtract the total here of 0.66, that's going to give us 0.16. So this will be our intersection. So now we can fill that in. Our intersection is 0.16, and this is for 4A. And then if we said this was 46, and we take 16 away from 46, this will be 0.30 now. And if this were 0.36 and we take 0.16, This is now 0.20. And if we add all of these up now, this gives us 0.66. And if we take that away from 100, we get out here 0.34. So for our answer, when we want to take the probability of Z complement intersecting with Y complement, we're getting the same diagram again, and the part where they're both colored is 0.34. And over here, again, we're looking for this clear area subtracted from 100. This gives you 0.84 here. And you can do the others. All right, so we've spent about 20 minutes just on this one lesson, but it was review from the past and hopefully helpful.